Aloha, Rich Halverson here. This is ITS128, and it is January 21st, the second class. And uh, I want to make an announcement right away. There will be no the class next week will not be at this time. Um, there will be no class next week. I will record a session, but I'm not sure when or where I'm going to do that. But so there's no class on January 28th at 1:45 to 3 o'clock. Okay, so that's my announcement. All right, so why don't I share my screen and get started here? And I don't want to share this one. Okay, put this one here. Okay, so I'm in Lamaku and I'm going to go to this is I think it's either this class or this class, but it doesn't matter. Both the same. Yours is one or the other. And I go to content. Oh no, I'm going to go to student. I want to be a student. And I go to content. Oh, it's just the last. Okay, this is the last video. No, that's I'm gonna no see no. I put videos on the I put videos on the playlist, and I haven't told anybody what the playlist is, have I? Okay, let's see if I can get to the playlist from here. YouTube to I've never done this before. ITS 128 spring 2025 Halverson. Ah, here we go. It's this one. So I gotta let me stop this. There is somebody online, so I'm going to copy this and put it in the chat for the participants online. But then I will but then okay, that's this video. That's the first video. But I'm gonna add it to a thing here, okay. Let's see. Am I recording? Yes, I'm recording. Anyway, all right. So I'll do that. And the last video, let's go to the textbook. I'll go to the textbook. Huh. All right. Okay. So this is the textbook, and the last time I got us all the way to I was doing the lab, okay, and the when I went home to finish the lab, I realized that the lab that I gave you was really a lab for like was a lab for chapter 10, probably. Okay, maybe chapter 10, or yeah, probably chapter 10 or maybe chapter 4. In this, so what I did was I replaced I fixed um, lab 1.14. Actually, I had to make clones of both labs. Okay, but anyway, so I made so lab 1.14 now is like how I started to do it um, uh, in the video last time. Okay, and it turns out I was going down the wrong path, but I'll correct that this video. And I was doing it where you have a program where you entered in the three parts of the phone number like this. You know, each part is on its own line. Each part is on a different line, and so that way I started out making a reading these numbers all on different lines. And it turns out that the instructions were actually, it was actually this lab that we were looking at. And in this lab, you enter in the phone number this way, and really is all in one line. You put the first number and then a space, just needs to be one space, and then the second part of the phone number and then a space, and then the third part of the phone number. And when you type that in, the rest of this is exactly the same. It's just that okay, so this is wrong. Is this how it? I don't think this is how it is when you see it, but this is actually the beginning. This is actually the beginning of the other one. So let me cut this out. And I'm gonna hope that's saved. It's actually the beginning of this one here. Okay, so and this is what I started typing, and this is this I believe is the answer to the first part of this one. So let me just run this and submit this for grading and see what happens. I should have done this before. Okay, so oh good, I got 4 points. Okay. All right, so now this goes along with the last video. Okay, so what I was able to do is go in and mess with these labs and change the solutions, the solution that I was looking for, and I made two of them. And what I did, you know, so now there's one more lab here. Well, if you go to the syllabus, I think I updated this. Yeah, so 114 and 115 are in the set of labs where you only have to do like 7 or something. Yeah, you do the, and this may have gone up to 18 now or so, but it's the best 10 out of 17 out of 18 now, I think, because I added one more. And basically it was just 1.14, and now it's 1.14 or 1.15. 1.15 is difficult. What you can do is after you learn how to work with strings, how to split strings. After you learn how to split strings, then you can come back to this one and do it because I don't discount for late homework. So if you want to, you can come back and do it later. But anyway, so that's what I've done. So why don't I finish? I'm going to finish this one, finish where we left off in the video that I forgot to tell you where it was. And I'll post it up. But anyway, so let's finish this. So the first part was you enter in this input, or you enter in some input. It doesn't, not necessarily these numbers, but it's 3 digits followed by 3 digits followed by 4 digits, and they can be any digits. Okay. So the first output is it just prints out the phone number like this. This is this is this, and this is this. Okay. Now the next thing is I'll put a phone number and add 100 to the prefix. Okay, the prefix variable should not change. Instead, add 100 to the prefix within the print statement. So in other words, we should have this. This is the print statement. Okay, well, I'm not going to be able to do it that way. See, so prefix should really be prefix plus 100. And we're using an F string. Okay, here we aren't using an F string either. Are we supposed to use an F string up here? Doesn't say. Anyway, so let's switch to F strings. Let's switch to printing something that looks this like this. And I'm going to put that here. So instead of having it this way, I'm going to do, and I'm going to delete the top. Print. Oh no, we're just paste it. Paste. And it's going to be oh. All right, so I'm gonna do this. Okay, I think that should be part of the. I'm gonna do this. I'm gonna do US plus 1 space area. I think I can just do this. Prefix hyphen last 4. Yeah. I think this is going to print out the same thing. And so I'm going to turn this into a comment. And I'm going to run, I'm going to submit this for grading and see what happens. Didn't get anything. Oh, prefix. Oh, what did I do? I meant pre. Oh, yeah. Yeah, I did mean that. So sorry. Oh, wait. This is. No, I didn't want to do that. I wanted to do this prefix. I wanted to do this because I wanted to print out the same thing. Okay. Same as what was above it. Yeah, right. Let's see what this does. No, I should get 4 points for this. Okay, good. So it did print out the way it was supposed to. It did print out the way it was supposed to. Now, the problem with what I have is I'm treating these still as strings. And so when I go to the next one, which is to print it out with the Brazil country code followed by the prefix number plus 100. In other words, instead of it being 457, it's going to be 557. Okay, see, for Brazil. So I cannot do plus. So I cannot do just plus 100. Let's see what happens when I do that. I want to see what happens when I do that. So I'm going to copy this, and I'm going to paste it over here, and I'm going to say Brazil. I'm going to say this. That'll be right here. First, I'm going to do, okay, and then I'm going to do what it said there, which was plus 100. And I don't think it'll work because this is a string and this is a number. Okay. And I should get a error because I'm trying to add a number to a string. Ooh, boom. Can only concatenate a string with a string. See, you can only concatenate a string to a string. You can't concatenate an integer to a string. And this was trying to concatenate an integer to a string. So what I has to do is change these to integers. Now, it would work if I were just to do this. I'm being lazy here. It would work if I just did that. I made the prefix an integer so you could do this, but the other ones aren't. Okay, so let's see what happens now. Okay, I got some more points. 6 now. And because I got the number it was supposed to get. But I haven't gotten Croatia and Egypt yet. So let's do Croatia and Egypt. That would be these last ones. So Croatia is I add 50 to the line number. And then Egypt, I add 30 to the area code. The variables should not change. In other words, I don't add them to the variables. I just add them when I print them out. So I do it this way. All right, so it's I gotta add Croatia and Egypt. Okay, so I'm gonna take this and I'm gonna copy it and I'm going to paste. Control V and Control V, and I want it to be. Oh, where's France? Oh, France is there too. I swapped the area code with the prefix. My goodness. Huh. Okay, so I'm gonna put France in there. Do. So I'm gonna do all these at once. Okay, I shouldn't do that. I should go one step at a time. In fact, I am gonna go one step at a time. I'm gonna take away that last one. Okay, so I'm gonna put Croatia. Copy. Paste. And I'm gonna put Egypt. Copy. Paste. And Croatia, I have to add, I'm adding to this. Croatia is, this is the same, but this is adding 50. Adds 50 onto that, isn't it? This plus 50 is this. So last 4 has got to be an int. And I can do plus 50. And then Egypt is plus 20. No, is add 30 to the area code. What's the area? Why, it's this one. INT. And let's put a plus 20. No, plus 30. Okay, let's see what this does me. Hmm. I was supposed to subtract 100 from the area code? No, I was not. Oh, I know the problem. I left that in there. I am not supposed to leave that in there. Yeah, that's better. Yeah. All right. Yeah. 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 Okay. There we go. Okay, I got two more points. And so now I just got to do France. So I can do France by going uh, copy, paste, and France is France plus 33. Copy, paste. And for France, I'm supposed to swap the area code with the prefix. 929,555. This is 555,929, and this is 929,555. Oh, okay. So I make this prefix prefix be that, and this is area. All right. So let's submit for grading. All right. Okay, so I got all the points. All right, so you know, lab 1-15 should be easy for you after you learn how to parse this into the three um, area or the whatever area code. Um, what's the second one called? Area oh prefix and line number. All right, so anyway, so let's move on. Were there any other? I don't think there were any other announcements. I did want to tell you. I can't remember if I told you the. I think I did. Yeah, I haven't gotten any questions about that. The because everything is auto graded, these due dates are really recommendations, and don't fall too far behind. But as long as you have everything done by the end of finals week, by May 17th, Saturday, May 17th, that's actually probably May 18th, Sunday, May 18th. That's when I download all the grades back from the very beginning from Zybooks. And so anything that you finished all the way back to chapter one, uh, anything that's completed will get counted. And I don't take off any points or anything. All right, let's move on to chapter two. And so chapter two, now we start talking about what a variable is and what an expression is. So, and how much time do we spend on chapter two? Just one week. Okay, good. So I want to get through some of these, some of the challenges and some of the labs. Participation verification. I don't know if I mentioned that. Yes, I'm sure I did. Just buy the book, purchase the book, or email me if you can't purchase the book. And that's how I'll know that you want to participate. All right, so if we go to so you should if you aren't familiar with programming, then these participation activities are real helpful to step through. If you do know how to program, they're kind of boring, but you just step through them and you learn the terminology of the book, or it reinforces what you already know, and it feels kind of good to have to go over something that you already know already. So here we're this concept of a variable. So we have a variable called number of people, and then we start doing stuff. We're operating in this variable. So this is like number of people equals the number of people plus 3. This is add 3 to the number of people. So then how many do we have now? We have 8. And then let's go to the next one. And then it says next. Two people get off. Well, it's number of people minus two. So that would make this 6. And then next we go to now 4 people get off. And now, so that's 6 minus 4, that equals 2. And then after that, 5 people get on. So that's 2 plus 5, now it's equal to 7. And next, it's 4 people get on. Well, what happens if I put the wrong answer? I'm going to put 10. Let's see what it does. Oops, skis. 7 plus 4 equals, I don't know, 12. Okay. 7, let's put the right answer. Okay. Anyway, okay, and then I get all the points. So that's the concept of a variable. And the other thing you have to design assignment statement. Okay, assignment statements are when you have some expression, something that computes to something on the right side, and then just the variable on the left side. So you have a variable here, and what this says is store the value 5 into the variable x. And this one here says store whatever is in the value, whatever the value is for x, we'll store that into y. And then here it's take the value for x, add 2 to it, and take that and store it into z. And this one just says take the value of take 3 and store that in x. So if we step through this, x equals 5, so it puts the x in there. And then we're going to y equals x, so it puts that in there. Then x plus 2 is z. And then x equals 3, that's going to replace whatever was in x. It's going to replace it with 3. Doesn't matter what it was before, it's gone. And then here, well, yeah, so all they're trying to say here is that in algebra, we're saying that whatever is here on this side is equal to whatever on this side. Okay, that's not what we're saying here. What we're saying is evaluate what is on the right side, and that gets stored on the left side. Okay, so in fact, you can have, x equals x plus 2. If you have like x equals x plus 2, then you take the old value for x, add 2 to it, and store that back into x. And that certainly wouldn't work with algebra. So anyway, this is not equal. This does not mean equals. Okay, it means assign the value. And in fact, in other programming languages, they don't use an equal sign. They use something like colon equal. And the prominent instructional programming language back in the 1990s was called Pascal, and Pascal used colon equals instead of just an equal sign to reinforce that concept. Anyway, so you can go through these. It's all a bunch of different ways of thinking about x, y, and z. Supposed to select the correct values for x, y, and z after the following statements execute. Okay, so I guess after these execute, x is going to equal to 9. X is 9, and y is 5, and z is 7. Is that right? Oh, I guess it is. Well, I just went backwards. Okay. You can do that because it's always you're just always assigning it to a number. If there are variables on the right side, then that wouldn't work. So anyway, okay, so good. Here's a challenge activity. Let's do this challenge activity. Remember that that when you do a print, that also includes a new line at the end. So create a new line after each output by pressing the enter or the return on your keyboard. Okay, fine. Let's start this up. And we're supposed to type the program's output. Print. So what is this going to print? Well, it's going to print 9, because that's what X is. And then it's going to print a space because in the print statement, when you put a comma there, it means put a space and then do the next one. And the next one is 5, so it's going to print out the 5. And then since it's a print statement, there's always an enter at the end. So that's what the first one is. Let's do the next one. Okay, print the output. Well, it's the same thing. 10 space. What's going on? What did I just do? 10 space 10 space 4. Enter. So hard about that. Am I doing something wrong? What's next? Oh, trying to trick me. First, it's just 6 and 2 they want printed. 6 space 2, enter. Oh, look at this. X equals 7. I wrote down what X equals 6. See, so I was wrong. So see, well, let's see what happens when this happens. Oh, it's different. So now it's 9, 2. 9 space 2, enter. Okay, you can do the rest. Okay, so you can have assignments with a variable on left and right. So like this. Okay, this is what I was telling you before. First, x is equal to 1. And then x is equal to whatever x was, which is 1, times 20s. So now x is equal to 20. And then we take what x was, which was 20, and we multiply that by 20, and 20 times 20 equals 400. So now, and 400 gets stored back into x. So that's kind of a thing there. So you can click through that and see that. Indicate the value of x after the statements execute. Well, at first x equals 5, then x5 plus 7 is 12. So now a 12 goes into there. And what's the value for x? It is 12. All right, there we go. Oh, this one looks harder. X is 2, y is 3. First, we're going to make x equals 2 times 3, which is 6. So now this is 6. And now this is 6 times 3 is 18. 18. Oops. All right. Anyway, so yes, so go through those step by step. It's just reinforcing your understanding of whatever we're doing here. Assign the variable of this with that. The output is 5. Oh, well, all we're doing is assign, start. Assign means code goes here. Num red fruits equals 5. That's all they're asking you to do. Yes. The next one is turns into an integer. Assign integer total books with the total number of books the reader now has. I guess it's I guess what they want is total books equals num books. I guess that's what they want. Oh. Oh, we're supposed to take this and add 10 to it. Well, the reader already has 10 books. That's what they meant by that. Okay, so I'm just gonna say, oh, do I get to do it again? I think I get to do it again. Plus 10. Ah, yes. Okay, very good. Okay, you can do the next one, which would be to, so we're supposed to take num necklaces equals num necklaces plus 3. That's what that's going to be. So anyway, you can do that. All right. Uh, identifiers. Okay, so identifiers are simply these, the names of variables. The what we can use for names of variables. And we can use, it starts with a letter. It starts with a letter or an underscore. It starts with a letter. Okay, it's case sensitive. It's case sensitive. It starts with a letter or an underscore, followed by as many letters, underscores, and digits as you want. Okay. So it has to start with a letter or an underscore though. So this is valid. This is valid. This is valid. This is valid. This is not valid because it's got space in there. This is not valid because it starts with a number. Nothing wrong with this. It can't have an exclamation point. I think this is okay unless it's what they call a reserved word. You can't use reserved words. And I can't remember if output is a reserved word or not. So I'm going to say it's valid. Oh, it is valid. Okay, great. Return S, nothing wrong with that. Okay, very good. All right, so now there are these style guidelines. And what style guidelines means, it's the preference of whoever wrote the style guidelines, okay? And you may want to have your own convention for writing variable names, for creating variable names, you know. And here they're trying to tell you for, like say the number of students attending a class, don't do that, don't do that, don't do that. You should do that. Well, whatever. Okay, it's up to you. Okay, these are the reserved words I was talking about before. So you can't have these as variable names. I'll see output there. Use the tool to test valid and invalid names. Oh, cute. Okay. I want to have a global, GL capital O BAL. It's a valid identifier. How about if I just have a lowercase? Bam. All right. So, objects. An object, um, represents a value and is automatically created by the interpreter when executing a line of code. So the meaning of object is kind of nebulous, and it never really used to matter so much in programming languages that the concept was crystal clear in your mind. It still kind of doesn't, but uh, some of it has to do with efficiency of storing things in the uh, storing variables and so on in the program. Uh, and but later on, when we get into objects, when we start talking about objects way later on up here, classes and so on, inheritance, those objects uh, are derived from classes, and then the concept of an object becomes very important. Okay, but for right now, we're talking about when we execute x equals 4, it creates a new object to represent the value of 4. Okay, so I don't know, what does that mean? It's a 4 in a memory location. I think it means a little bit more than that. But anyway, like for example, the type, it's treated as an integer and not treated as a character. So, you know, whatever the character mapping code is, with that equals 4. Whatever the character is that is mapped into the number 4. And I don't know what that is. It's some non-printable character. But anyway, all right, so you can go over this. And there's what's called garbage collection too, because when you're done using objects, they take up space. And so the underlying operating system has to be smart enough to go in there and clean out and return empty space back to the pool of usable memory for your program or for other programs. Properties, value, type. So each Python object has 3 defining properties: the value, the type, and identity. And this is the identity part is kind of it's kind of a little bit confusing to me because let's say we have something like this and it creates a value of 4. Well, it's not just a memory location out there, which we're going to call X, and there's a number 4 in that X. That's not quite how it is in Python, and we need to sometimes be aware of this. There's also a concept of mutability and immutability. Mutability, if the object can change, if you can change the value, if the program can change the value, then it's mutable. It means you can mutate it. It can mutate into something else. If it's immutable, that means it's a constant thing. The program creates it. If it creates it as a 5, it has to be a 5. If you want to change, if you have a value x that's equal to this 5, and you want the value x to equal 6, well, you have to make a new object that has the value 6 and assign x equal to that value. Meanwhile, this object that has the value 5 is still there, it's still around, but it's just not being used by anybody. And then that's where the garbage collection would come in. Return it to the pool of memory that can be used in the future. Anyway, so that's the concept of objects. I don't know how you would even test you on that, but okay. So now let's talk about some of the other kinds of numbers. There's numbers that are like integers, which are, they don't have a decimal point, and then there's numbers that have a decimal point. And these numbers that have a decimal point are called floating point numbers. And then there's scientific notation also, and that's where you got an E in there, which stands for times 10 to the. So this is 1 times 10 to the minus third power, which would be 0.001, I think. Yeah, this is 1 times 10 to the minus fourth power. Minus 4 means it's going to be a 0.0001. Anyway, E equals MC squared. Anyway, so the size of a number inside that a computer can hold is finite, obviously, because there's a certain number of bits in the computer. There's a maximum size and everything, and sometimes you'll be doing a computation, and the result of the computation is a number that's too big. It's too big, and it can't be stored in the computer. And when that happens, the processor detects it, and it raises an overflow exception or causes an overflow error. In other words, there's an overflow. Your number was too big, and there weren't enough bits in the word to store the number. So that's that concept. Manipulating floating point output. A lot of this comes along when it comes time to print. So this is these are F strings, how you print a number with 2 digits, a floating point number with 2 digits to the right of the decimal point. Let's see. Oh, look, here's a challenge. Time is it's 3:30 and we are in section 2.4. It closes. Okay, let's just do one of these. Number of gallons to paint needed to cover a wall is equal to the wall's total area divided by 350. That must mean a can of paint can paint 350 square something. So complete the program to output the number of gallons of paint needed to cover the wall, rounded to 5 digits after the decimal point. Okay, so I guess we got to use something like this. And oh, it's already here. We just have to write the print statement. We read in the wall area. We make it a floating point number. We divide by 350, and now we got this number of gallons, and now we just have to print it out using something like this. And my float, it's not my float, it's gallons. So I'm going to copy this and put it there. And then it's not capital XF, it is 5 digits after the decimal point. So I'm going to just take a wild guess here and put a 5 there and run it. Oh, look, very good. Excellent. The reciprocal of the volume input is 1 over the volume input. The following program intends to read a floating point value from the input and output the reciprocal, but the code contains an error when reading from input. Fix the error. Well, I would guess that the error is that the volume input is if the volume input is this, we're converting it into an integer. And if you convert this into an integer, it's just going to end up 0. So we don't want int, we want float. Start. F. Float. I think that'll work. Ah, yes. Let's do the next one. A polynomial is given by Q equals minus 10 times M times M minus 2 times M plus 5. Read M from input as a float. Then compute Q using the polynomial. This is just an equation. It's like an assignment statement where this equal sign means an assignment, means assign the value Q, whatever that computes to. Polynomial just means it's got, this is M that's squared, and this is M that's different than this M. It's not squared. And if you have M to the 3rd power, that'd be a 3rd order polynomial. Anyway, oh, that's pretty clever. They tell you that. So what am I supposed to do? I'm supposed to do Q equals minus 10.0 M squared minus 2.0 M plus 5.0. Okay, well, that's crazy. Of course, it's not this. Let's fix it. Okay, minus 10 times m times m times m. Remember, it says m equals m. M squared can be m times m. Okay, m times m minus 2.0 times m plus 5.0. And I know they like us to have all these darn spaces over here and there. Let's put some more spaces there. Okay. I think that's all we need to do. So in this problem, and a lot of programming is this. When you're a programmer and you're out in the real world and you're working with some engineers or technicians or whatever, and you're the programmer, and you're supposed to program what they come up with the equation, and then you write the program to compute, to do the computation. And they're going to give you something that looks like this thing, and you got to convert that into something like this. Okay, so you don't need to come up with this. You won't need to come up with it. Someone else will come up with that. What your skill will be is to take some massive equation that's got square roots and all this and that and convert it into one line. Let's see if this is correct. Oh. Hmm. I have to have a Prince Q. This is Q, Q. Oh, I have to read it in. Do I have to read it in? Oh, geez. M equals float input. Is that right? All right, there we go. Yes, now it's got output. All right. Next one. Complete the program to output the value of the length, a value of this thing, to 3 digits after the decimal point, followed by the word millimeters. So, hmm, I don't get this, but whatever. Okay, so this reads it in as a floating point number, divides it by 1,000, gets this thing, and what we're supposed to do, we're supposed to write it out. Is that all? This? Okay. Print. F. Quote, or I mean, left curly, length underscore millimeters, colon, point 3 F. Close the curly, close the quote, close the parentheses. Oh, and I gotta say millimeters. Why it's I don't the problem to me doesn't make any sense, but all right, so okay, so you can do the next one. All right, arithmetic expressions. Okay, so now we're talking about all the kinds of stuff that can be on the right side of an assignment statement. All the stuff that can be the expression that gets evaluated, and then that it gets evaluated into a single value, and then that gets stored into the variable that's on the left. And so these are all the kinds of operators. Well, these are all the things you have to know about, and you remember this from high school. Parentheses, you do stuff in the parentheses first. And then this is the symbol for exponent. So back on these ones before where we were doing something times m or m times m. Where are those? So you've seen it. You of course know what addition, subtraction, multiplication, division is a slash. Asterisk is like raising it up to that power. So it's like you can't do superscripts. So you just do asterisk. Which are valid expressions in X and Y variables. This is valid, that's fine, that looks good. This looks good. This looks good. This looks good. This doesn't look good because there has to be an asterisk. If this is 2 times X, then there has to be an asterisk in the middle there to mean times for the times. So it's not valid. Same with this. If this is X times Y, you see, this could be a variable XY. There can be a variable called XY. But that's not what we're talking about here because there's a variable X and a variable Y. So they make it clear up here. But if you were just to put this in the right side of an assignment statement, and these are the variables, all they would say is you're using a variable XY and that hasn't been defined. It's not going to say, oh, you left out the asterisk, because it's just going to think that's a variable. Anyway, so this is not valid because it's not X. So anyway, and then this is not valid because an expression is just that part. So this is not valid. So you should know how to, that this means this, and this means this, except for this is not really an expression because it's got to be an asterisk. So I bet you the answer is no. Yeah, the operator is asterisk, not X. And so this is, yes, that's true. No, it's got to be an asterisk in there. Yeah, I think that'll work. Yeah, that's is it? No, I don't know. I don't think that'll work. Yeah, it doesn't do anything for that. All right, you have to write a program. If you want to compute this, you have to write a little dinky program to do it. Okay, and then precedence rules. Precedence. Some people pronounce it precedence. Anyway, I pronounce them precedence. Okay, so you know about parentheses. You do what's inside the parentheses first. Exponent. Oh, this is precedent. So if you have an expression, and there's a bunch of, and there's some parentheses in there, and there's some exponents in there, and there's some unary, some like this is the unary minus sign. There's some of the asterisk for multiply, slash for divide. This is a modulo operation. So anyway, so when you have a mixture of these, the first thing you're going to do is the stuff inside the parentheses, and then the next you're going to do the exponent things, and then you're going to do the unary things, and so on. So anyway, you can see how that works. And if you want the order to be different, then you just use parentheses, because if you want something to be, evaluated first before something around it is evaluated, then you just put parentheses around that thing that you want evaluated first. Let's do these precedence rules. Which operator is evaluated first? Well, the divide is, because divide has precedence over plus. And it's also on the left. It's also left to right. If they were the same, it'd be left to right, and it would still be divide. So what's the next one? Oh, next. Which one's evaluated first? It would be the minus n, because that has precedence over, it's not going to be n divided by 6 and then minus that, although it would be the same. Oh, whatever. Anyway, so that's right. Which operator is evaluated first? Well, multiplication and division have the same precedence, so it's left to right, and so the multiplication would be first. And now, which one has precedence? The multiplication has precedence, because the parentheses makes it so the multiplication is first. So that's why it's multiplication. And the last one is, which operator is evaluated first? The plus sign, because it's inside this. The plus sign. What's evaluated second? Well, it's going to be either this one or this one. And a divide has precedence over subtraction. So it's going to be the division symbol. And then the last one will be the minus sign. All righty. So here's an example, and you might see this later. So you might see it written this way. And what this is you take the guy's age, multiply it by that, take the guy's weight, multiply it by that, take the guy's heart rate, multiply it by that, and then you add all those together, and subtract this from it, and that gives you this thing. And then over here, I guess you can just take that and multiply it by time, and then you can take that whole thing and divide it by this. And for women, it's different. Well, you can't type this in to a Python program and have it work. It won't understand square brackets and all that. It won't understand the X. So you have to write it this way. This is how you would write it, and Python would understand it. You notice the X's are asterisks. The parentheses there's the inside parentheses, outside parentheses. You still use parentheses. So these are the outside parentheses. And then the inside parentheses are, this is 1, this is 1, and this is 1, so on. Consider the example above. Match the changes that were made. This underscores. Underscore. Oh, spaces in variable names. Oh yeah, heart rate. Yeah, underscore. So spaces are replaced with underscores. Minus sign is replaced with a minus sign, and a X replaced with an asterisk. And let's see, calculate the values of the integer expressions. This is pretty easy. Just do one of these. X equals 11. Y equals 11 plus 3 is 14. Print Y, print 14. Yeah, easy. Okay, so you can do those. Python expressions. So here we're just below is a simple program that includes an expression involving integers. Would removing the parentheses as shown below yield the same result? So it's this, and if we were just to remove the parentheses, would it yield the same result? Yes, it would, because multiplication has precedence over addition anyway, so you don't really need to put the parentheses there because it's going to do the multiplication first anyway. So is that right? Yes, it is. Would using two assignment statements as below have yielded the same result? Okay, so first we're going to have this into that, and then we're going to add the down payment to that. Yes, it would. Total cost, yes. Total cost here equals the same as total cost here. So yes. Sometimes this is more clear, especially if you have a big long huge equation and you're trying to see if you can type it in right and all that kind of stuff. A good practice is to include a single spacer on operators for readability. Well, that's personal preference. I'm a minimalist. I kind of like this minimalist, but it's your own personal preference. You may work in a team of programmers, and you may all, since everyone's got to look at everyone else's code, you may agree on some convention. There's things called compound operators, and that's like if you have some variable that's on both sides. Like here, you just want to add 1 to the value of age, so you do this. Take age and add 1 to it. That's how you do it. Subtract 1 from age. That's how you do it. And so you can do it this way, where you have plus equals. That's just like this. Here you have minus equals. That's just like this. And it also works for multiplication and division. And this is the modulo operator. We'll learn about. This is the remainder. This is when you do a division, and you know how if you're doing integer division, like 7 or 13 divided by 2, or no, 13 divided by 5, it's going to be 2 with a remainder of 3, right? 13 divided by 5 is 2, the remainder of 3. And so 13 mod 5 is 3, because it's just the remainder. That's that symbol. And we're going to use that a lot later. So this is showing you how to use the these compound operators. All right. Yeah, of course, don't put comments. Okay, expression for the acceleration of gravity is this. So we're supposed to do this formula and have A equal that. So I think that works. So, okay, you read in a D and you say A equals, start. A equals G times M divided by D asterisk asterisk 2. And so you want to do this first. Well, the asterisk asterisk 2 will make sure that this gets computed before the division takes place. So let's see if this works. Oh, good, it works. Now, I'm curious, can I do it again? What happens if I do this? Times D. See if this works. Okay, this does not work because G times M divided by D times D is not the same as this. See, this, what I've written here is actually this. And that's not the same as, let's get rid of this one. Really what we want is this. See, we want to compute the top and then compute the bottom and then divide the top by the bottom. And so this works. See, this works. Got all the right answers. Or you can get rid of all the parentheses and put asterisk asterisk because asterisk has precedence over multiplication and division, or whatever. Okay, so anyway, so you can do the rest of them. Division and modulo. This explains about dividing. You're dividing a slash. If you use a slash, it's a floating point division, and you'll have a number. You can have numbers to the right of the decimal point. You can have decimal numbers. If you want a division where you discard everything to the after the decimal point, then you could do a double slash. And so you know when you do integer division, you do you have the dividend and then divisor and then the quotient and then the remainder. And this will give you just the quotient. And then the remainder you get with the modulo symbol, this. And this will be reinforced a lot. Anyway, so it's 3 o'clock. It's over. I'm gonna make a video for next week, and I'm gonna post it up before Tuesday. And I'm gonna finish chapter 2, and I will I'll finish chapter 2. I'll do some more labs. I'll do a couple labs, and then I'll also do chapter 3. And that'll be in my next video, which I'll post up just before Tuesday. Maybe I'll post it on Tuesday. All right. Are there any questions? All right. Well, thank you for coming, and I'll see you next time. Thanks.